How do we solve matrix multiplication equations using inverses? Well, what are inverses good for? Well, the idea is that A times A inverse is going to be the identity matrix. So this is useful when I give you something like A times B equals C. I give you A, I give you B, and you want to find C. What you can do is you can multiply A inverse on the left of both of them. Oops. And if we multiply A inverse on the left of both of these, then this becomes the identity matrix, so we get B is A inverse times C. So this is one way we can find out one matrix given another multiplier and their product. So a message X has been coded into the matrix Y using the encryption key K. So Kx equals Y. What is the message? So the idea here, the strategy here is we have this equation, and we're going to want to take K inverse first, and then we're going to want to multiply K inverse times Y, and that will give us what X is. So let's start by finding K inverse, and that will involve Gaussian elimination. As a reminder, the idea of Gaussian elimination, the strategy behind Gaussian elimination, is to get all zeros in one of the columns, and then once you've gotten, all zeros in one of the columns except for any one entry, then you can use the two rows that have zeros in them and solve that system using a scalar multiplication. So this time what I'm going to do is I'm going to get this this column to have zeros, and specifically I'm going to have these two have zeros. So the idea is if I take 1 plus negative 1, that'll give me 0. If I take 4 plus negative 4, that'll give me 0. So what I'm going to do is I'm going to add row 3 to row 1, because that'll give me 0 here. And I'm also going to add 4 times row 3 to row 1. To row 2. The point of that is that this second column will turn into 0, 0, 1, and that's good for us. So now let's calculate out the rest of the matrix. We're adding row 3 to row 1, so 3 plus negative 2, negative 3 plus positive 2, 1, 0, 1. This becomes 13, 0, and negative 15, 0, 1, and 4. We left row 3 the same. And now that we have two zeros in the same column, we can focus on those two rows. And using those two rows, if we take a multiple of one of them, add it to the other, then we should be able to get more zeros. Specifically, 13 is a multiple of 1. So if I take negative 13 times the first row and add it to the second row, then that will cancel out here. So we'll get negative 13 plus 13 will give us 0 there. That way we'll have 1, 0, 3. I'm going to fill out the rest. I did not change anything about the first row. I'm doing negative 13 times this is positive 13 minus 15 is going to be negative 2. We have negative 13, 1, and negative 9. And 1, negative 3, 0, 0, 1. Similarly, we can take negative 3 times the first row and add it to the third row. And that way, our first column will be all set up. So negative 3 times 1, 1, negative 3 times this is 3, this is negative 3, 0, and negative 2. Next, I want, so this row is set. This row is close to being set. We need this to be a 1. So I'm going to divide that row by negative 2. So 1, 0, negative 1, 1, 0, 1, 0, 0, 1. I'm going to divide this by negative 2 by writing out the decimal. Positive 6.5, negative 0.5, and positive 4.5. Then 0, 1, 0, negative 3, 0, negative 2. Now we can add a multiple of the second row to the first row in order to get rid of this negative 1. So we add row 2 to row 1. That'll give us 1, 0, 0, 7.5, negative 0.5, 5.5. Leave the rest the same. And lastly, if we switch these two rows, then we will have the matrix on the left be the identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So 7.5, negative 0.5, 5.5, 6.5, negative 0.5, 4.5, negative 3, 0, and negative 2. Did I actually switch them? No, I don't think I did. So I need to switch these. That's going to be negative 3, 0, negative 2, 6.5, negative 0.5, and 4.5. There we go. Now we have our inverse matrix. This is our inverse matrix. So we're going to use that inverse matrix with y, and we're going to take that inverse matrix times y, and that'll give us our output. So let me make a new page. Here's matrix y. Here's our inverse matrix. So I don't want that. That's big. All right, so I want to multiply these two matrices together, and that's going to be, that will give us our message. So this is going to be a large calculation. 7.5 times negative 24 is negative 15 times 20, times 12, which is negative 180. We're doing negative 0.5 times negative 101. That's going to be 50.5. And we're doing 5.5 times 25. That's going to be 127.5. The next entry is going to be the first row times the second column. So that is negative 187.5 Negative 0.5 times negative 63. This is where a calculator is good. 31.5. 5.5 times 30 is 165. 7.5 times negative 18. That's 9 times 15, which is negative 135. Negative 0.5 times negative 72. You can fast forward through this. I think you know how to do the arithmetic. 5.5 times 18 is 99. We have 72. Well, this row is easy because of the zeros and the small numbers. Negative 2 times that is negative 50. Negative 3 times that is 75. Negative 2 times that is negative 60. Negative 3 times negative 18 is 54. Negative 2 times that is negative 36. Now we're doing 6.5. Now we're doing the last column. Sorry, the last row times each of the columns. So 6.5 times this is negative 12 times 13 is 156. Negative 0.5 times that is 50.5. 4.5 times that is 112.5. Yes. 6.5 times negative 25 is negative 162.5. Negative 0.5 times that is 31.5. 4.5 times 30 is 145. Now we're doing 6.5 times negative 18. 9 times 13, negative 117. Negative 0.5 times 72. And 4.5 times 18. Now it's just addition is left over. So we add these up. Negative 180 plus these two is 8. Adding those, we get 9. Adding these gives us 0. These subtract 22. This is 15. That's 18. This is 120. This part is 163. So that would leave us with 7. The 145 was part of this. So these two are 17.5 apart. Adding that there is 4, if I did this correctly, and 0. So that's what I believe I should have gotten if I made some mistake in my arithmetic. This is definitely what the answer is supposed to be. And that gives us this message, 890 22 15 18 740. If we match up H is the 8th letter of the alphabet, I is the 9th letter of the alphabet, etc. WORLD, hi world is the message. So that was the message that was encoded from the beginning.